Okay, so review of exponent laws. As I said, I'm going to leave a lot of that for you to do. So the first chart, guys, that's basically a chart that you probably had in Math 10. It is something similar in Math 10. You're going to complete that on your own. Okay? Right-hand side is practice. We're going to do the second, question 1, the second row of them. Okay? So, things to remember for negative exponents. So this says simplify, first of all, and express answers with positive exponents only. So finish it off, right? There are some cases where you can leave powers with negative exponents, but if you are asked to express with positive exponents, then you got to do it. So the biggest thing is to don't forget about the 5 in here, the coefficient. So you can do this. There's a couple ways you might do this. You might raise each factor to the exponent -2, or you might decide, I want to make that a positive exponent. How do I do that? Well, that applies to the whole bracket, so I'm going to take the reciprocal, or flip it is the non-math word, to make that a positive exponent of 2. Then you simplify that. Okay, so simplify doesn't have brackets anymore. So now that's going to be 1 over 5 squared is 25 e to the 8. Okay, common mistake is I will get this. Okay, what went wrong? You forgot about the 5. Okay, people are good at squaring e to the 4th, but they forget that this has to be squared as well. So that's a common mistake.
But you're multiplying it together. You're multiplying by itself. Here. That's correct.
Okay, next one. So notice how this one has a rational exponent on it. So that you could show as a radical, but don't. Right? We know that we can go back and forth, but don't. This is in power form. We're taking -2x to the 3/2 to the exponent 6. So we're raising everything inside to the exponent 6. So really, that's -2 to the 6. And then x, 3 over 2 multiplied by 6, that's going to be 9. -2 to the 6 will be a positive. Okay? And what is that? 4 times 4 is 16, times 4 is 64. Okay? So 3/2 times 6. Again, common mistake I will see will be 18 over 12 when people multiply fractions. Oh, that's where I go crazy. Yes.
There was no brackets around the -2, so technically shouldn't that be read as...
Yes, there is a big bracket.
Not around the 2 part. So shouldn't that just be, the negative is considered separate from the 2?
Nope. It's all in a bracket.
I mean, it wouldn't change the answer anyway.
I don't know what you're asking.
Like, okay, so the negative is separate from the 2 here, so you could also rewrite that as -1 times 2 times x 3 over 2.
Why would
divide 6 to the -1 as well. Which here, it wouldn't matter, right?
It's -2 to the 6. Same as -1 to the 6.
No, what I'm saying is if it was a odd exponent, then it wouldn't matter.
Yeah, we could just take -2 to the other side.
Oh yeah, no, it wouldn't make a difference.
Yeah. You just apply that to that coefficient. That's the coefficient, right? Don't make it more complicated than it is. Okay, next one. So here, there is a negative exponent. I'm not going to deal with that right now. I'm going to deal with the bracket raised to the exponent 3 first. Nothing to do here. So that's going to be -4. You need to show it like that to start. Do it. Okay? Don't forget that the -4 needs to be cubed. Then that will be a to the -6 times 8a to the 7. Okay? Now, -4 raised to the exponent 3, that's an odd exponent, so it's going to be a negative value, 64 again, actually. times 8, actually I'll do that all at once. So this times this will be negative, what's 64 times 8? 248, 512. Okay, so the coefficients part, then a to the negative 6 times a to the 7 is a to the 1, which is just a. Okay, you don't need to be talking, folks. If you have a question, raise your hand. Otherwise, think inside your head. Okay, so here, that's why I didn't deal with the switching this, because maybe once you multiply everything together, you don't even have any negative exponents anymore. So why create more work for yourself? Okay. So that is question 1, DEF. Now we're going to look at question 2, the second row as well, EF, G, H. Okay, you can go back and do the other rows, but that's the next one you're going to look at. Okay, so we're going to look at this one. So these involve rational exponents. So we had some in the last, but now each one of these has some rational exponents. Okay, so again, if we've got brackets, that exponent of 1/2 applies to every factor inside them. So 16 to the 1/2. Well, that's like the square root of 16. Square root of 16 is 4. Okay, if you have to show the work, you can, but why? Yep. Nope. That's only when you're solving an equation. Okay, that's a positive. So gives you 4, and then x to the 4th raised to the 1/2. 4 times 1/2 is 2. Okay. The only time you get x, you get plus or minus, is if you have this and you're solving, right? Because when you put these back in, you get 16 out. Okay. This is always, when you take the square root of a number, it's always the positive square root. We call it the principal square root is positive. Okay, so then this has a negative exponent. So you could raise each to the negative 1/2. But how about, because that's on the outside, I'm going to make it positive first. Make it positive, you flip it. Right? That bracket is around the whole fraction. So I'm going to flip the fraction to make that positive 1/2. Okay. I'm going to go back to full screen here. Okay, now I raise everything in there to the 1/2. So x squared to the 1/2 is just x. 64 to the 1/2 is like the square root of 64. Okay, so those were 1/2. Now we'll look at 1/3. That means the cube root, if you were to think about it in terms of radicals. So now, cubed root, so we're raising 125 to the 1/3. Don't show it separately. You can do that in your head. That's going to be 5. And then x to the 6 raised to the 1/3. You multiply those exponents together. 6 times 1/3 is 2. Okay, again, negative exponent on the outside part, so I'm going to make it positive rather than raising each of these to negative exponent. So that's going to be 1 over 27x to the 9 raised to the positive 2/3. If you have a question, ask. Okay, so now think about what 27 to the 2/3 is. you're in grade 12 math, you can do this. Cube root of 27 is 3. 3 squared is 9. Okay. How else could you do that? You could say, okay, well, 27 is 3 cubed to the 2/3. 3 times 2/3 is 2. 3 squared is 9. For who? Well, you don't need to like lean on him. Okay, so next part, x to the 9 raised to the 2/3. Multiply those together. 18 over 3 is 6. All right. Turn over the page. Okay, so question 3 we're going to skip. We're going to go to question 4, because this is really what's going to end up being helpful at some certain point in this exponential function unit, is expressing powers with the same base and then simplifying. So it says express each of the following as a single power with a base of 2 or base of 3. So this can be, can't do both, right? So if you look at 32, I can't show that with a base of 3, but I can show it with a base of 2. 2 to the what is 32? To the 5. Okay, so you need to know that for the exponent and when we get to logs. Okay. Next one. Back in when you first started this, I might see something like this. Ugh, what did the person do? Practice? Yeah, so they added the exponents, which you do if you are multiplying powers with the same base. But those don't have the same base, so they decided, oh, I'm just going to multiply the bases together. Okay? Don't do that. I see it. It drives me crazy. Okay? So, we want to show it as a single power, so we've got to look at the bigger base and see if we can show it as with a base of 2, the smaller one. So 4, so I'm copying out 2 cubed, 4 is 2 squared. Okay, so 4 to the x is 2 squared to the x. So that, if you want to go straight to this, you can, right? 4 to the x is the same as 2 to the 2x. Now, you can show that as a single power. Okay, because they do have the same base, so you can add the exponents. Okay, so next one, you could evaluate 16 to 3/4, okay? Or you could show 16 with a base of 2 and 8 with a base of 2, because you're going to have to simplify it all together. So, totally up to you. 16 is 2 to the 4th. So if you know that you can evaluate that now, you can go for it. If you do this, you can evaluate this. So however you think about it, sort of the best way. So this 8 is 2 cubed. I'm square rooting it, and then I'm cubing that. Right, so there's your radicand, there's your square root, there's your outside exponent. So this becomes 2 cubed. This becomes 2 to the what, 9 over 2. And now add those exponents together. What's 3 plus 9 over 2? 15 over 2. Okay. So in D, we've got a base of 1/2 and a base of 64. It says in the question, show with a single base of either 2 or 3. So I don't want to show with a base of 1/2, I'm going to show with a base of 2. So this is the same as 2 to the what? Negative x, right. And then 64 is 2 to the what? 6. Okay, then power over power, you multiply those together. And then you multiply powers with the same base, then you add the exponent. Okay. The next row is all with base groups. Same types of questions, so I'm going to leave that for today. And then we're going to do question 5B. Same kind of thing. Express with a single power. You want to convert those radicals to powers. Okay, so we're going to do this one. So square root of 5 cubed, what's that with a base of 5? Square root of 5, what's that with a base of 5? Root of 5 to the 4th, what's that with a base of 5? So do each part of it, and then use your power laws to simplify. So 3 over 2 plus 1/2 is 4 over 2, which is 2. Then we're dividing powers with the same base. So you want to subtract your exponents. So that would be 6/3 minus 4/3 is 2/3. Okay? And really it doesn't evaluate to anything nice. So I just leave it like that.
I wrote it as 25.
You do it 25, yeah.
I think that's nice.
Okay. Right hand side, solving equations involving exponents. So there's that question that someone asked about. X squared equals 9. What are the solutions to that? Notice how it says value or values. You might have more than one. Right? Take the square root, both sides, plus or minus. Because that value, you're not told that it's the positive square root. There's no square roots in the original equation. It's a quadratic. So then you're working to find the two values, or any values that satisfy. So positive 3 squared is 9, and negative 3 squared is 9. here, cube root is just 2. No positive or negative. So what were we doing here? So I use radical symbols, right? Square root of both sides, cube root of both sides. I could, same question here, rather than doing cube root, I could raise both sides to the exponent 1/3, the reciprocal of this. Right? 3 times a third is 1, so I'd end up with x to the 1, which is x. 8 to the 1/3 is 2. Right? So you can either do your radical form or raise each side of the equation to the reciprocal of that exponent. And that might help you with question 7a. Okay, so 7a, x to the 3/2 equals 27. So based on what I did in this one, the reciprocal of 3 was 1/3. The reciprocal of 3/2 is 2/3. Whatever you do to one side, you have to do to the other. If there was more than one term on the side, very rarely would you do that. Okay, because then you can't take the raise each term to 2/3 because those are added together, right? Only factors. So here, that multiplies to 1. Now, 27 to the 2/3. So you're finding the cube root of 27, which is 3, squared, which is 9. Okay? Then you be careful. You're taking the cube root of both sides. So you only have positive here. If you were taking the square root, then you would have positive or negative. So there you go, question? So now this one's a little bit different. This is x to the 2/3. So reciprocal of 2/3 is 3/2. Okay. So x equals, now the square root of 16 is positive or negative 4, and then we're cubing it. So that's going to be positive or negative 64. Okay. So now, because I'm taking the square root and then cubing, so when there's an even denominator to both sides, you can have positive or negative. You can go check. Put it back in. Positive 64 raised to the 2/3. You get 16. Negative 64 to the 2/3. You get 16. Test them out. Okay, and then C, reciprocal of 2/5 is 5/2. So now we're taking the square root of 4, both sides, so that's plus or minus 2, and raising it to the exponent 5. So x equals positive 2 cubed and negative 2 cubed. So plus or minus 32. Okay, so here, negative exponent, remember a negative times a negative is a positive. So if I multiply this by negative 5/2, but sorry, raise it to the exponent negative 5 over 2, which makes that multiplying of the powers. Same on both sides, then I'll just get x on the left. Now, I'm going to actually show this because it's a little bit squishy. I'm just going to show that out. Okay? Rahul, shut up. I'm talking. Well, who was? I swear it was. Your mask was moving.
I'm eating.
Go keep eating then. Okay, so someone, I think it's the guy behind you then, is talking.
Man has no life left.
You good? Just look at your own stuff, right? You're good. Okay, so here, I'm going to make that positive exponent. And so now, I'm finding the square root of 4, which is 2, raised to the exponent 5 is 32. So x, now saying that, what did I forget? Plus or minus. So not, so here, I haven't taken the square root yet. I haven't done it yet there. So here, plus or minus with the 32, but remember you just put that out front. We never like to show a negative in the denominator. Can you check it? Well, let's see. In this case, let's go back, put in, say, you want to check if it's negative. So, bracket, some of you have a fraction p. If you do, I'm going to put the negative in, fraction of 1 over 32, bracket, then raise that to the exponent, again, negative, fraction 2 over 5. So you get 4, you get 4. So you know that your negative works. And then you can do the same with the positive. If you don't have the fraction capability, then you just do divide. You could also graph it. Solve graphically, right? Left side, right side, where do they intersect? Okay. Here, we need to isolate x, just like any equation that you solve back in junior high. So divide both sides by 2. Okay. Then we have x to the 3 over 2, so we want to raise that to the 2/3, both sides. So that goes to 1. And then the cubed root of 64 is 4 squared is 16. Do I need plus or minus on that one? No, because it's the cubed root. And again here, I need to isolate the factor of x. So 5 divided by 125 is 1 over 25. Okay. Then, because it's fractions, what you could do is change the sign on that, which would take the reciprocal on the right side. Proportions. Okay, so you could do that and then solve from there, or following the same steps that we have been doing, to the negative 3 over 2 would give you x equals, so 1 over 25 to the negative 3 over 2, to make that positive would be 25 to the 3 over 2. Okay, you don't flip this fraction, that's your exponent. And then, now you're taking the square root of 25 and cubing it. Do I need plus or minus? Yeah, because it's the square root. Alright. Alright, so that is sampling from the review.